Hey guys, so today we'll be performing a limiting reactants experiment. These are the material that we will be using. For 250 ml, 4 balloon label 1 to 4, a tape, measuring spoon, funnel, acidic vinegar, sodium bicarbonate, and a 100 ml beaker. So the purpose for this experiment is to determine what happens when sodium bicarbonate reacts with acetic acid. The chemical formula for this reaction is Na8CO3 reacts with HC2H3O2, which produces NaC2H3O plus H2O plus CO2. So each container of 250 ml contains 100 ml of vinegar. Number 1 balloon has 1/4 teaspoon of baking bicarbonate sodium. Each container has 250 ml, which contains 100 ml of acetic acid. So balloon number 1 measures 1/4 teaspoon of sodium bicarbonate. So what we will be doing is, without spilling the sodium into the bottle, is stretching the mouth of the balloon over the container like this. We will be repeating this procedure for the following. This second balloon contains 3/4 of sodium bicarbonate. We will be stretching the mouth of the balloon, placing it on top, of the bottle without spilling sodium. This third balloon, labeled 3, contains 1.5 teaspoon of baking soda. So carefully putting the balloon over without spilling sodium inside. So the fourth balloon contains 3 teaspoons of sodium. So we'll be stretching the mouth of the balloon and placing it over it. To secure our experiment, what we will be doing is placing tape around the balloon to hold it in place. We will be doing this for the following 3. That sodium bicarbonate, which is the baking soda, and the vinegar, which is the acetic acid, will react together, and what will happen is that a double displacement will occur. The sodium, when reacts with the vinegar, it will produce sodium acetate and carbonic acid. So when sodium bicarbonate react with acetic acid, it forms sodium acetate and carbonic acid, which the carbonic acid will undergo a decomposition reactant, making water, which is H2O, and carbon dioxide, which is CO2. So this balloon 1 has 1/4 tablespoon of sodium bicarbonate, and this is the reaction. So what causes the balloon to expand is that carbon dioxide is being produced. So this other balloon contains 3/4 tablespoon of sodium. So it will react 1.5 tablespoons of sodium. This other balloon contains 3 tablespoons of sodium. So the difference is that each balloon expands larger. This balloon is the smallest because it contains limited amount of sodium bicarbonate. This balloon here contains more and this. So these are the difference between the reactions. As we know, this contains the least amount of carbon dioxide and this contains the largest amount of carbon dioxide. The difference is that each contains different amount of sodium carbonate, and the similarity is that all of these reactants or reactions had 100 ml of vinegar. So we were given two problems. Question 1 have A and B, and question 2. Question 1 stated if 1/4 of tablespoon of baking soda is used and it estimates 1.25 grams and it is reacted with 100 grams of vinegar, how many moles of carbon dioxide will produce, and identify the limiting reagent. So what we'll be doing is putting the 1.25 grams mole of sodium divided by the 84.006 of sodium. So sodium will cancel sodium, and you're going to times it by 1 mole of CO2 because we are finding CO2, and we're going to put 1 mole of NaCHO3, which is the sodium, to find how many moles of carbon dioxide are in sodium. So when you do this calculation, it will give us an calculation of 0.015 mole of carbon dioxide. Then we could go on by saying that 100 grams of vinegar will be divided by the molecular mass of vinegar, which is 60.052, and times 1 mole of carbon dioxide divided by 1 mole of vinegar, and it gives us an estimate of 1.665 mole of vinegar. So as we could see, the limited reagent here is sodium, which is the baking soda. Then question number 2 asks a 10-gram sample of sodium bicarbonate will be reacted with the excess vinegar, which is the acetic acid of 111.88 grams of carbon dioxide was collected. Calculate the theoretical yield for this reaction. So what we'll be doing is putting the 10 grams of 1 mole of Na8CO3, which is the sodium, divided by the molecular mass of sodium, and once we do this division, it gives us an estimate of 0.119 mole of sodium. Then the 111.88 grams times 1 mole of CO2 divided by the molecular mass of 14.01 of sodium give us an average of 2.542 moles of carbon dioxide.